So recursion is a process of defining a function in terms of itself. We will get into recursive stacks, which are a key component of recursion. We have a function factorial and we have a parameter number. And we're calling print factorial of 3. So when we call factorial of 3, it is going to run through all of this code, and we will go through this in detail, but when we run it, we will see that it prints 6. And notice how we have called the function factorial within the function definition here. Writing out the recursive stack is one of the most important steps towards being able to write recursive solutions. If you are able to draw out what you want to return on every step of the process, then you will be able to solve any recursion problem. If we look at this, in the beginning we call factorial of 3. Factorial of 3, number is going to be equal to 3. It's going to check if number is equal to 1. That is not true, so it's going to skip that, go to else. Return number times factorial number minus 1. So that's what we have here. Return 3 times factorial of 2. Notice the fact that I have not actually finished executing this line here. We have been caught in a recursive stack. In order to solve factorial of 3, we have to solve factorial of 2. So that is why this is called a recursive stack, because the computer is going to generate another stack, another copy of this function here, in order to solve the highest level function, right? We have to solve for factorial of 3, but in order to do that, we have to first solve for factorial of 2. So we're going to do that. Now, we're going to have another stack, which is factorial of 2. Number is going to be equal to 2. It's going to check if number is equal to 1. That's not true. Return number times factorial number minus 1. So now we are returning 2 times factorial of 1. Now in order to solve for factorial of 2, we have to solve for factorial of 1. So now we've created a third stack in the process of evaluating factorial of 3. So we have the highest level stack. Now we have the second level stack. Now we have a third level stack. Now we're going to call factorial of 1. And this time, it's going to check if number equals 1, return number. Notice there is no recursion here. So whenever you are defining a recursive solution, you always should have a base case like this. A base case is a case where the recursion ends or it stops. So we get to this last point here, and we're at the end of the stack. Now the computer is going to ask itself, have we finished evaluating factorial of 3? And the answer is no. We've got to the end of the stack, but we do not have an actual value for factorial of 3. So once it gets to the end of the stack, the computer is going to say, okay, I can't go left, I can't go right, I can't go down. The only way I can go back is up. So it's going to plug 1 back into factorial of 1, because we know that factorial of 1 is equal to 1. So it's 2 times 1, which is equal to 2. Now 2 is going to plug itself back into factorial of 2. 3 times 2, which is 6. And now we can plug factorial of 3 equal to 6.